Hey everyone, so we're going to continue with the work that I didn't get a chance to do in the lecture. I'm going to show you how to set this up so it'll work. First thing that we're going to do is we're going to set up our variable. So I have path point right here. Actually, I really want this, should rename this. This is really my path list. So this is my list of my path points. And I've created as BP of path points. In the document, I have made it an array of actors. Either way is perfectly fine. I'm going to stay with the BP path point because that's basically, we made that specifically for us. It needs to be public, which is instance editable. Continue on. We need a path list index, and that's going to be of type integer. That doesn't need we'll default it. We'll make it public for right now. It doesn't need to be. We'll compile and make sure it has a default value of 0. Next variable that we need is the current point, and it's going to be basically going to be our BP path point. So since we're using the path point here, we will just use it right here. We will make this public. We don't need to make it public, but we'll make it public for our sake argument here. So we can see, and basically we're only making these public so we can see them in the editor. They would normally not be public. The next variable is going to be our move speed, and that is going to be a float. The next variable is going to be our move direction, and that's going to be a vector 3. And I'm going to make this visible because it'll be visible in the editor. Move direction, we won't need to make that visible in the editor. Finally, we will have another float. And this is going to be point within range. Again, our last two variables are going to be booleans. So this is going to be has dynamic direction. This is going to be a boolean, and then just for the sake of argument, we will put a is active. And I'm going to take all of these and I'm going to put these under the path runner category that we created. And I can move them around like this right here. So they're all part of this right here. I'm going to just turn these all on. Now, normally all of these wouldn't be visible. Like the move direction wouldn't be visible. But for our sake of argument for right now, we will make it visible so we can see it in the editor. But like move direction, current point, and the path list index, these would not be visible in the editor normally. We wouldn't have access to muck around with them as we see fit. So those are the variables we need to set this up. We do now need a couple methods, and we're going to use functions in this case. And the first one's going to be next path point. We're going to do set move direction. We are actually going to do a move runner script. And this will simplify our code effectively. The next one is going to be a check distance and update. So next path point, when we need to change our path point, we will call that node. Set move direction. So when we need to change our move direction, we'll call this. And there'll be two. So basically, two scenarios is we've hit our check distance and update. This will basically call these two functions effectively. Again, set move direction. There's a scenario where we're move runner. This will get called right away. So these are the methods that we need to do this. So there are two events. First is on begin play. Let's go back to our event graph. We will not need event begin overlap. So all our work is being done. It's going to detect it by position effectively. So begin play sets the current path point item to 0 in the path list. So our variable path list index we are going to set, and we're going to set that to 0. Our current point, again, we're going to set that. We're going to get our path list, and we're going to use a get. And in Unreal, they use get a copy. What they mean is get a copy of, basically get a copy of the element that's in the array. And we are going to basically plug this in because it is going to be 0. So this is effectively what we want. I'll put this up here so we don't cross streams. And that's the point that we're going to set to be the current point. And make sure we exact across, so that's what we're doing. So this is going to set us up, and then the last one we're going to call is our function set move direction. And that will set us up. This sets our index to 0, gets the point out of the array, sets it to the current point, and then we will use move direction to do what we need to do. I'll just compile that. So let's jump into, we'll come back to tick in a moment. Let's do some of these functions first. So let's do the set move direction. So set move direction basically calculates b minus a. So this is going to be between our default. So we're going to get a reference to our default scene route, and then our current point. These are the two values. Now it's going to be a is our default scene route and b is our current path point. So so what we're doing is basically our current point. We are going to get we will get the actor location. And we are going to, here we're going to get the and get world location. So here are our two different locations. And then it's going to be our subtraction. So we'll pull this out, hit the minus sign, here subtract. So here is, the A vector, B vector. This is the A and B inputs, but this is the B where we want to go and where we're at. So let's pull this together so it looks nicer. I'll grab this down, and this is, I'm gonna hit C. This is our B minus A. Our direction vector. Now we know this. Now we have this is the direction we want to go. The one thing that we have to do with this vector is to normalize. So, and then finally, what we'll do is we have a move direction variable which we'll set. So the normalization will go right here, and then we just have to connect it across. And that's all that we're doing with our move direction. We could, in theory, let's get a reference to self. And just for the sake of argument, we are going to basically say set let's set the world rotation on the default scene route. And we are going to, now it should, if we try, it will convert the rotation from a vector to a rotator type. So this will set the forward facing of it. So Unreal has basically a rotator type and its legacy. It knows that if you try and give it a vector 3, it will translate that to the rotation type that's internal to the engine. The rotator exists way before we got into using quaternions and doing efficient math, and there's history behind it, and I've talked about that previously. So this is just setting the forward, this is just setting by basically, let's make this a little bit cleaner. Move these out a little bit. And I'm going to select these all and hit C, and that's going to make our comment. This is going to set forward rotation. And what we may need to do, you may need to later on, we may need to, one of the things that you may need to do later on after we normalize this, well, actually, what will probably end up happening, if we're getting issues of it putting up or down, we can go through here and break this. We can, again, show break. We'll just break the break this link. Split structural pin, split structural pin. So right now we're going to just basically plug in these values right here as it is. But later on, one of the things that we can do is we can break the Z and leave that as a 0. And then just normalize the X and Y value. So it's only facing down the X on the XY plane and not looking up and down. We'll worry about that another time. So we'll compile, and we're all good. So that's our one of the first functions is, we've got our set move direction. I am literally going to grab this right here, and I'm going to copy it. Because one of the things we need to go down and check distance and update. So I'm going to paste this down here. And for our purposes, I'm going to recombine the struct pin for our purposes here, because what we want to do in this case is get the magnitude. Here's vector length. And literally we can now say if this value is less than or equal to, and the other value that we want is our within point range. So if it's less than that value, if that's the case, then we need to connect this across. So if that's the case, then what we need to do now is we're going to get our next path point. So we've reached our target, we're going to go to our next target. So go to the next path point, and then we're going to set the move direction. So off it goes. And that's all we need to do here for the check distance update. This is just something to make our life easier to do. So we're dealing with, so this right here deals with all of this efficiently for us. Try and get you more room so you can see what's going on. So here is check distance update. We're going to get the V minus A vector, subtract it, get the length, check against the point within range. If it's within range, then again, if that's true, then we have our next path point, our next move direction. So we've done 2 of them. We've got set move direction. So I'm going to close these tabs, check distance, and then set move direction. All right. Our next path point. So the first thing that we want to do with our next, so basically we are going to use an index to go through this. First thing that we want to do is get the next path point get the index. And put this right here, and then we're going to increment it by 1, and we're going to do this basically there's an incrementer operator. So it will get it, and then it will get it and set it for us right away. Cool. And then out here, it will be the path index plus 1. The first thing that we need, and so ideally, again, we can go to our path list, and we want to get a copy at our index, which we'll just copy and paste this. So this is going to be our next target. So we will assign that to current, make this a little bigger so you can see current point. And this is going to be a set that. And we'll plug that in here. All right. Now we could connect these right away, but the problem that we have is that if we go beyond our the index is outside of the range, then getting this will be all messed up. So what we need to ask is if this point is greater than or equal to, and I use greater than or equal to just to be on the safe side. If that is greater than or equal to the, again, it's going to be our path list, and it's going to be the length. So it gets the items that are in the array. And if that's the case, what we need to do is an if statement. So let me drag these nodes a little bit further away. Let me put these up here for right now. So if this is so, what's going to happen is after an increment, we're going to do the if statement. If that's true, we need to get, where is the index? So we need to set pathless, that's a get. Sorry, we need a set. So in this case, we need to set the pathless index to 0. And once we've done that, and this, what we need to do is then set the current point. Now I'm going to create I'm going to add a reroute node here, and I'm basically going to connect this reroute node to here and then to here effectively. So this needs to happen regardless if it's true or false. We need to move on and do it, but we need to go up here to do this one operation, set the index to 0. If again, what's going on here? If we're equal to the length number, so again, let's say we have 3 items. First item is going to be 0. Second item is going to be 1. Second item is 2. We get to the third path point. It will advance it forward. It will be 3. That's equal to greater than 3. That means we got to go back. That means we're outside of the. So that'll be outside of the range of what's in the array, the list. And so we go back to 0. And so we go from 1, 0, 1, 2, and then back to 0. 0, 1, 2, 0, 1, 2. And that's an example with just 3 elements in it. And that's basically, again, regardless, we have a true scenario and then a false, where basically after we do what we need to do here, we come back. So this is something that you should be aware about, is that you can continue on both true and false, depending on your situation. And I'm going to compile, and we're good. So that is basically our next path point. All right, so now that we've got that, we can now go into move runner. And so for our purposes right now, this is setting up so that we can just throw a whole node and to move it. This will need an input, and it's going to be, we're going to do delta seconds. And this is going to be a float. Now, there's one thing that we have to do here. We're going to account for it right now. We're going to get this has dynamic direction. And and we're going to do the work here for it. And it's basically going to do an if statement. If this is true, and we're going to go down here. If this is true, we need to call set move direction. If that's not the case, then we're going to just go there we go. So I'm going to put a reroute node here. So basically, if that's true, we need to do this. Otherwise, we're going to go on and proceed with what we need to do. And so what it's going to multiply is multiple delta seconds times move direction times its move speed. And then add that to the world location of the scene route. So one of the things that we can do is we can promote to a variable. Is that what we want? Let me just check. No, it's not what we want. Let's go back to the. Let's not promote that to a variable. Let me undo that. We'll just use this internal. Let me see. Oh, promote to a local variable. I used the full variable. So this is local. This is going to be delta seconds in mover. So basically, we're going to plug this in. So the first thing we'll do is basically move this over as well. It's going to plug it right there. There we go. So we're going to make delta seconds a mover just so that we can make our lives easier, so we're not dealing with wires all over the place. Then we'll check dynamic direction, so it does update move direction. And then finally we will take, we need reference to delta second mover. We need our move direction. This will be the first variable. And then our move speed. I'll put these right here. I'll bring these down. And this is going to be a multiplication. And we are going to add a pin so we can connect move speed to the second pin, and then the delta seconds on mover. So again, by making this a local variable, we'll set this here and we'll use it down here. So we're not like dragging this wire all the way over the place. All right, so this is now the change in position from where we are to where we're going to be. The next step is going to be, we're going to take our default scene route and we're going to get world location. So this goes up. So this is going to be, we're going to add, so we're going to start with the vector here, and we'll add to the world location. And this is going to be our new location. So now we can do, I'm going to grab the default route one more time, and we're going to set world location. And we just plug that into new location. And we need to bring all of these down. Let me grab all of these. There we go. And I'm going to bring this up just a little bit. I'll plug it in like there. There we go. So now there's, so after, depending on, so based on that, we will do all this math. And I now can pull these up a little bit to make this. easier to read. In fact, we can move this up. So now we've got a node that will move this. Again, the first thing it does, it checks, stores the here in the local variable to make our lives easier. Checks if it has dynamic direction. It does that if it does. And then it just goes down, again, does the mathification, adds it to our world location, assigns it to the world location. So we move. So this is moving based on position. And now that we've got that, we can now go back to our event graph. Okay, we got next path point, so we can go to our event graph. So we're going to be moving on tick. Now the first thing is we will have an is active. Get is active. And that is, again, this is there if that's true, then we'll carry on. I'm going to move this up here to make our lives a little bit easier. Because the next thing that we're going to do is we're going to grab our set move runner. If that's true, then we'll plug in the delta seconds. And that's going to be our, let's see, we just do one tick. So we pass, again, we check if X is true, we call the move runner function, and then we'll call the check distance and update function. And again, this only operates if we are within range. And it calls next path. And that's all that we need to do to set this up and going. So we're going to jump back to, so I'm going to go over everything one more time. So let's start, we're going to start with check distance. B minus a directed vector, and we use this in another function as well. Our current point minus the location of our location of our scene route. We subtracted that. In this case, we needed the vector. We checked it if it's less than point within range. So here's our if statement, our branch. If that ended up being true, we called next path point and set move direction function. Move runner. First thing is we stash delta second into a local variable for our reference to make our life easier. We ask if then does it have dynamic direction? If so, we need to do this branch on the true statement. If not, false. When we're done here, they converge on this reroute node, and then that reroute node then sets the world location. We then set. This is our delta. On this frame, and we've added it to our world location. I may actually want to move these out a little bit more because I can pull these down and make another comment. And this is going to be our new world location. And I'm hitting C to create these comments. So don't be afraid to use them. And what's nice is that you can then click on the box itself and move them around. And hey, there's a unit of stuff. Compile again. So that's the move runner. We did set move direction. In this case, we got our direction vector. We normalized it. And this is going to be, again, I'm going to grab these. And I'm going to do a new comment. This is going to be our new So it's our new direction, and it's normalized for use. Again, we're moving by position by this vector, so we're not using the forward direction of an object in this case. So just be mindful of that. So here's our set move direction. So here's that piece right here. And then here is, we set it. And this is the forward rotation. Now we might need to change, like break the Z. We'll see later on. We shouldn't at the moment. But if we were dealing with the Z issues, we can, it rotating up in ways that we don't want it to. This is one place that we could do it here. In theory, we could break this link here. We can in theory break the links here instead, and do in this one we can do this one more of the ways. Actually, this would probably the way we might do it is right here. Set rather than breaking it here, we could break it here. Let me explain that further. Let me make this a little bit bigger. Bring this down. So we'll break this link, split the struct pin, break the struct pin. Again, I'm going to bring these in this way right now. But if we were having an issue with the rotation, we could break the Z, and so it's only facing X and Y. So it'll go up and down, but it won't tilt up and down respectively. We'll do this later on, or you can do it later on for if you're again right now. I know all our points are on the Z plane, so I'm not worried at the moment. So I will compile this again, and that's our set move direction. And then next path point. The first part is, and we need to. Increment the path with index. So I'm just going to pull this out. All of this right here is to validate that index is within range of the array. And then finally, right here is then this is finally assign get next point from the array. Just did the set move direction. Again, that makes it very easy. Just validate that if we got an if it's active, do what we need to do. If this is off, then we're not moving. Set move runner. The node is pretty straightforward, and then get checked up. This is an update. Let's set us up. Make sure that we're set up for our next tick. Again, initialization is up here. Actually, I will comment this is to. Call it the initialization for the first tick. Hello, why are you acting weird? There we go. So I'm just going to go in. We have, again, on the path runner, we have set current point. No, where's path? Here's the path list. And I'm going to move, and that should have been moved to, go back. So it has, I'm not sure why it's giving me two. Well, I'm not going to worry, but basically we're going to look at the values here. Move speed, again, we'll just go back and set move speed. We'll set that to We'll set that to 500. We're gonna move kind of speedy right now. I'll do 250. We'll go too fast. Again, we're using Unreal, so this is you know what? This is 250 centimeters, which is that's a box we put down as 100 units. So, and we should be good to go. And why is it not moving? Because it's not active. And there it is. So now we did make those. Oh, it's going off. Why? So I'm just going to go into my path point. One of the things that we did was we did we made the cone hit it in game. So we're going to just turn that off. And we're going to look at the path runner. Oh, the other thing that we're dealing with right now is we didn't do point within range. We didn't set that. So we'll set that to 75 right now. And we can see it's going to that point, and it goes to that point. So we've got to add some values. So we didn't set a move speed. We didn't set that. We didn't set it to be active. And there goes the fourth point back to the first one. And there we go. And that is basically what we needed to do to finish off this assignment. So I know I've gone fast, I've gone quick. I should have been able to pause the video at times to get what you needed to see. So if you need to see screenshots of the blueprint graphs, ask me. Send me a message and I can do that for you. So all right, good luck everyone. You should be able to complete the assignment now.